This video will be a short review of finding key features of quadratic functions and using them in order to get a good graph. And the example we're going to use is the quadratic function y equals negative 2x squared plus 4x plus 3. And you might first take note of the fact that because the coefficient on the x squared term is negative, this is going to be a parabola that opens down once we graph it. First of the key features, because it's sort of the easiest to find, get us off to a good start, is the y-intercept. And the way we find the y-intercept given any equation is simply to plug in 0 for x, because the x-coordinates of all the points on the y-axis are 0. And when we do that, we get 0 plus 0 plus 3, and it will always, in the case of a quadratic, just be the constant term. Then we need to find the x-intercepts, and along the x-axis, of course, y is equal to 0. And so we want to set y equal to 0, and that in turn is equal to negative 2x squared plus 4x plus 3. We need to solve this equation. Now, in order to do so, you could employ a number of different methods, but probably the quickest one, unless you see an easy factoring of this, is to use the quadratic formula. And we should recall that if ax squared plus bx plus c equals 0, and a is not 0, then x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is a thing you simply have to know at the level at which you're studying. And so in our instance here, x is the opposite of 4 plus or minus the square root of 4 squared minus 4 times a, which is negative 2, times c, which is 3, all over 2 times a, which is negative 2. We can make this a little bit nicer. This is negative 4 plus or minus something over negative 4. And the something is going to be 16 minus negative, so plus 24. It's going to be the square root of 40. Now, there are some opportunities here for simplifying, but rather than going through that process, we're just going to reach for a calculator and get approximations, and we find that these values are about negative 0.58 and about 2.58. So those are our x-intercepts. We also are going to need to know the location of the vertex. And one way to find its x-coordinates, if there are x-intercepts, is just to take the mean of the x-intercepts. But a cheap thing that one also can do is to recall that the x-coordinate of the vertex is the opposite of b over 2a. So in our case, that's the opposite of 4 over 2 times negative 2, which is 1. If we then want to know the y-coordinate of the vertex, we simply stick the x-coordinate back up into the function. And so we have negative 2 times 1 squared plus 4 times 1 plus 3, and that feels like about 5. And now I have all the information that we need, and so we can go ahead and set up some scales and make a graph. In the x direction, we're covered pretty well if we just go by ones, so maybe I'll call that 5, and I'll call that negative 5. And similarly, in the y direction, we have to capture a y-intercept of 3, and we have to get up to a y-coordinate for the vertex that's equal to 5. So that should work out pretty well. And then we just locate these key points. We have the vertex at 1, 5. We have the y-intercept at 3. We have the x-intercepts at about negative 0.6 or so, and about 2.6 or so. We can make use of some symmetry to grab ourselves another easy little point. And then, knowing the shape and knowing these key locations, we can make a pretty good graph. And that constitutes our quick review of quadratic functions.